So last time we were talking about points in the coordinate plane, and we talked about the distance between 2 points. So just real quick, we covered the quadrants, the name of each quadrant, and the sign of x and y values in each quadrant. We saw that x and y are positive in quadrant 1, x is negative, and y is positive in quadrant 2. Etc., etc. So we had every combination there, just with the signs of x and y's. And we also learned that if something is on an axis, for instance, if a point, I may not have explicitly written this down, so let's get it down now. If a point is on the x-axis, then it is of the form, well, what is its y value if it's on the x-axis? If it's on the x-axis, then its y value is 0. So it's some number x and then 0. So just some number here, wherever the point might be. I'll just say arbitrary like x. It could be, 1 or -2, whatever. And similarly, if a point is on the y-axis, then it is of the form. Now, if it's on the y-axis, then its x value is 0. So 0, comma, and then whatever the value is for the point. Okay. We'll have a name for these points later. We'll call them x-intercepts and y-intercepts, but for now, this is fine. All right, and we talked about the distance between 2 points. So given 2 points, 2 very generic points in the xy plane, how can I make them generic? I just call them xy. But if I want 2 points and I want to be able to distinguish between them, I call this the first point. So I subscript both of their letters with a 1. I call this the second point, so I subscript both of the letters with a 2. So given 2 points, x1, y1, and x2, y2, the distance between the points, is, and then we have this nice clean formula coming straight from the Pythagorean theorem. D is equal to big square root. And how do I remember this? How do I remember this without having to look at it? Because of the way I say it, it's the square root of, and then I can say the difference of the x values. So what does difference mean? This means to subtract. What are the x values? Well, these two, right? So the difference of the x values squared. So this is how I would describe it. Difference of the x values squared plus the difference of the y values squared, all under a square root. So if you ask me, how do you remember this? It's because I know how to say it in words. And when you can say it in words, you can start to memorize it, right? Like one way to memorize things is to make flashcards, right? But imagine, making a flashcard of this and you have to spit this out when you see this flashcard. Well, how the heck do you say that, right? Like quickly. You have to learn to interpret these math expressions and equations in words. That's going to help you to memorize it or to remember it. So the difference of the x value squared plus the difference of the y value squared, all under a square root. Also, one way to help remember these things is just to understand where they're coming from and to understand that it really is just the Pythagorean theorem. That might be a little bit more of a stretch right now. You may not see that. I proved it last time, but maybe it's still a little. When I say that this is just the Pythagorean theorem in 2 dimensions, that may not click yet. That's okay. All right. The point is knowing the formula and knowing how to use it. So last time we did one. So I'm not going to do another one because we did an example given 2 points and we found the distance between, and note that it is a number. The distance is some number. The next thing we want to look at in this section, which is 1.1, so we're continuing with 1.1, is the midpoint formula. midpoint. Okay, midpoint formula tells us the, let me give you a picture of what it tells us, and then we'll write down the formula. So if given two arbitrary points, x1, y, so I'm going to label them the same way. So x1, comma, y1, and some other arbitrary point, x2, comma, y2. So the same way that I've labeled two arbitrary points for the distance formula. Where is the midpoint, the center point between these two values? Well, does anyone remember how to find the middle between two numbers just on a single axis? Like on the x-axis, what is the center between 4 and 6? You would probably say 5, right? And what are you doing when you find the center of two numbers? So to find the quote unquote, I'll say middle of two numbers, you just find their average, right? Okay. We find their average. So if I said, what's the central number, the middle number between 4 and 6, you would say 5, but also that's just finding the average, 4 plus 6 divided by 2, which is 10 divided by 2, which is 5. Okay, so to find the middle between two numbers, we take the sum of the numbers and we divide by 2. That's how you find the average of two numbers, right? That's standard finding the average between two numbers right there. For the midpoint, we want to find the average of the x values. So remember that this is a point. This is a coordinate point. It's not going to be just a single number. It's going to be a whole coordinate point. We'll say capital M for midpoint is going to be equal to the average of the x values. So x1 plus x2 over 2. And then how do you find the center between the two y values? Well, very similarly, y2 or y1 plus y2 over 2. That's it. So again, how do I say this in words? How do I find the midpoint between 2 points? The x coordinate is the average of the x values of the given points. The y coordinate is the average of the y values of the given coordinate points. Okay. So here we go with example 2. So I told someone last time, because someone, I forget who, was asking about this this particular formula, and I said that it would be very intuitive. And hopefully you see that here, like, okay, midpoint literally means like the average of the 2 points. So how do you find the average of 2 coordinate points? You just find the average of the x's and the average of the y's and stick them together in a coordinate point. So let's find the midpoint of the points, let's say -2, 3 and 0, 4. Okay, Makira, what did you get for the x value of the midpoint?
Give me 1 second. I was doing something.
Okay, that's fine. Let's see, while we're waiting, let's see. Devin, what did you get for the y value of the midpoint?
Three and a half.
Yes, or we can also just leave it as 7 over 2. So we can say 7 over 2, or we can write that as 3.5. That's good. And then the x value would be, Makira, what did you get?
-1.
Good, -1. Okay, so just in case, if we're not clear on where those came from, let's say I'll do the details here. So m is going to be, the x value is going to be the sum of the two x values from the coordinate points divided by 2, and then the y value is the sum of the two y coordinate points over 2. Of course, -2 plus 0 is just -2. -2 divided by 2 gives me -1, and then 3 plus 4 is 7. And over 2, which, as Devin said, we can write as 3.5. And if you wanted to graph this point, if you did want to graph this point, you would probably want to write it like 3.5 so that you knew where to put it, right? Like if you actually wanted to draw these 2 points and then draw this point, finding out where 7 over 2 is it's easier to think of it as 3.5 or 3.5. That's going to be easier to find on the graph. So, but either one is perfectly fine. All right, so that's pretty straightforward. That's pretty much 1.1. Section 1.1 is understanding the quadrants, understanding how the points act on a graph, right? Like if it's in quadrant 4, then x should be positive, y should be negative. If they're on an axis, if it's on the y-axis, that the x value is 0, and vice versa on the x-axis. Knowing the distance formula, knowing how to use it, and knowing the midpoint formula, knowing how to use it. So 1.1 is a pretty straightforward, compact section. In fact, it may even seem more familiar than that 0.4 section, which tends to be the trickiest section for students starting off in this course, that rational exponent stuff. So hopefully this is more comfortable for all you guys, more comfortable with graphing points and stuff like that. And we're actually going to continue with that in 1.2 now. But first, let me say, let me see if I can fit it here. A problem to mark for review. I think I've been giving you problems. Maybe I missed a section, but these are just extra problems from the back of the textbook, or rather from the exercises in the textbook that you can find in your ebook, just for extra practice. And I wanted to give you one from 1.1. I can't find it. Oh, it was 25. So 1.1, number 25. It's a 3-part question. It's just given 2 points. You got to graph them, find the distance, find the midpoint. Okay, so that would be a good practice problem to add to your big review assignment that you're going to do before the exam. Okay, let's move into 1.2, which is graphs of equations. So now we're going to be graphing equations, graphs of equations in 2 variables. Which, yeah, definitely only 2 variables because we're only dealing with a plane. If we went 3 variables, then that would be 3-dimensional space, which we're not going to do in this class. And circles. Circles as well are going to pop up here, which it doesn't have to be its own thing. It's going to be an equation in 2 variables, and we're going to graph it. So, all right, here we go. First of all, what does it mean to graph an equation? What does it mean? Does it mean to graph an equation that is in 2 variables? What does it mean to graph an equation that's in 2 variables? Well, first of all, what is an equation in 2 variables? It's something like, well, there's lots of different examples, but I could say an example of an equation in 2 variables would be like y is equal to 2x plus 1, which is a linear equation that you are comfortable with or you've seen, right? And you know that this is the graph of a line, or maybe you remember it now that I said it, but where that is the slope of the line and that is the y-intercept. The point of this is not to tear apart this equation and talk about how it's a line or whatever. I'm just saying that I'm giving an example of an equation that's in two variables. It just means an equation has an equal sign, two variables, x and y. Another example could be like y squared is equal to 81 minus x squared, something weird like that, where both of them are squared. And now this is a completely different shape that you may not know. You probably don't know, and that's okay. We'll talk about that. Or you could have a, y equals just x squared minus 1, something like that. Okay, so an equation in two variables is just an equation that has an x and a y. I should say it doesn't have to be x and y, but if we're going to be graphing it on a plane that we call the xy plane, then yeah, let's let the letters match xy, right? Okay. Now, I still haven't answered the question of what does it mean to graph an equation in two variables. I've just given examples of equations in two variables. So what does it mean to graph them? A graph of an equation is all of the points, xy points, that satisfy the equation. What does satisfy the equation mean? That means you can plug it in and you get equality. You get a true statement. So for example, let's take the y equals x squared minus 1. Here are some points. So if I wanted to graph this, I need all of the points that satisfy the equation. If I need to start listing points that satisfy the equation, I can just start picking x values. So let's say 0. And what is the corresponding y value that satisfies this equation if I plug in a 0 for x? So Nikita, if I plug in 0 for x here, what is y going to equal? So the x goes away.
Would it be positive 1?
Well, it would be 0 minus 1, which the negative would stick around. So it would be negative 1. Okay, but the point is that when I plug in 0, the x term goes away, right? Well, 0 squared is 0, and just keep in mind that 0 minus 1 is the negative sticks with the 1 there. Okay, so this is one point out of the infinitely many that satisfy this equation. Another point I could say is one. Well, let me give you a more interesting point, like 3. Nikita, what would this one be? If I plugged in 3 for x, what would the output y value be?
2?
What is 3 squared?
6.
No, remember, exponent means multiply it by itself.
Oh, 9, I'm sorry.
So that's okay. So 9 minus 1.
It's 8.
Yes, so there's another point that satisfies this equation.
Oh, okay, I'm sorry. I forgot the whole square root was there. I was doing a 3 minus 1.
Oh, yeah. Yep. Okay, so there are infinitely many points. There are infinitely many points. Infinitely many points that satisfy this equation. Okay, points that satisfy this equation. There are infinitely many points that satisfy it. I could not list them all for you, right? I could list a lot, but then like I skipped, even if I went from 0 to 1, what about 1/2? What about 1/3? What about 1/48? You know, there are infinitely many. There are infinitely many. points that satisfy this equation. Also, there are a lot of points that don't, right? Like if 0, 0 doesn't satisfy, if I plug in 0 and 0 for both of these, I don't get equality. Okay, so what is the point here? What does it mean to graph an equation in 2 variables? It means we're going to, so to graph an equation, in 2 variables. To graph an equation in 2 variables, we find enough points until we become convinced about the shape of the graph. Convinced about the shape of the graph. What does that mean? Well, because yeah, like how many, does that mean? I'm going to be helping you with that. I'm going to give you some tips that tell you if it's looking like this, you should probably get this many points. Here are some important points to check, specific values to check. You're going to want to make sure you go into the negatives and the positives. So we're going to talk about that. We're going to talk about more about this part, about becoming convinced about the shape of the graph. So for y equals x squared minus 1, so let's just keep working with that. Consider y equals x squared minus 1. Now, if we're going to be finding a lot of these points, let's get organized. And instead of having like a big list of, coordinate points, you've seen this before, we're going to make a little table with x values and y values. What is the y value, by the way? It should output x squared minus 1. So instead of y right there, I'm just writing what the equation is equal to there. You can do that when your equation is solved for y. Not all of our equations are going to be solved for y, so you won't be able to always. Sometimes you'll just have to put x, y. We'll do an example of that too. And if you don't like this, you can just put y here. If you just like to put a y there, that's okay. All right. Some good points to find, I'm going to go ahead and list them here, would be the whole number, or rather the integers between -2 and 2. Okay, so for each of these, I'm going to ask you guys to compute them, and I'll put your initials next to each one so you know who is going to do each one. So let's see, I'm going to go for people I haven't
I
picked on.
can't see like whatever you're writing. I can't see. It's like still frozen on the problem before.
Oh, yeah.
Yeah, mine is frozen too.
Yeah, mine's also frozen.
Okay. Let me check my Wi-Fi. Oh, that's not Wi-Fi. Hang on. I'm connected to the 5G here. Hang on. One second, I'm looking for, while I'm looking for a solution, which I may not be able to do while we're in a meeting. For those whose video is frozen, which might be all of you, leave the meeting and come back to it and see if that fixes it. You should be able to just join the meeting again straight from the Teams calendar. Okay, did everyone come back or are we missing? Let me see if anyone didn't. Okay.
I left and came back and it froze again.
Okay.
Yeah, it's froze on this end too.
So you can't see that. Well, let me try switching my cameras. God, what a glorious piece of software. All right, so camera, I'm gonna switch to my webcam, which is, I know it's just dark right now because I have my webcam covered. It didn't do anything.
Mine's working now, I think.
Okay.
It kind of like keeps going in and out, like it freezes some and then it doesn't.
Yeah. Are you guys on campus?
I'm on campus.
Yeah,
Yes.
that's probably why the Wi-Fi trash.
Yep. That's probably it. Sorry.
Because nothing's pulling up on my laptop either. So I think it's the campus.
Yeah, okay, well, then that means that, what does that mean? I mean, well, I won't be able to necessarily call on y'all. I mean, because I can just keep lecturing, but if you can't see, then there's kind of not a big point in me keeping you here, but I mean, we got to figure something out. So, I know there are some things you can do to make your Wi-Fi better on campus. They sent out a list of things last semester. Like if you're in a dorm, there are certain things, something to do with your microwave being too close to your laptop, some crazy like that. I don't remember. Let's keep trying to go through. The lesson is being recorded, so you can always come back and watch it. But let me do something. Let me take attendance. How do I do that? And if it just keeps freezing, and you can only hear me, then I'm not gonna be like offended if you just leave and watch the recording later. So if it's just frozen, you can just leave the meeting and just know that it'll be up an hour or so after our class ends. So roughly like 2 or 2:30, it'll be up. Okay, so I'm going to keep going. So obviously not going to be calling on anyone just because of the Wi-Fi issues. Okay, so we're considering y is equal to x squared minus 1, and we are making a table of values with x in the left column and the y value in the right column, and the x values are ranging from -2 to 2 integers, -2, -1, 0, 1, and 2. And we're going to be plugging those in and finding that y value. So -2 squared is 4, minus 1 gives me a 3. -1 squared is 1, minus 1 gives me a 0. 0, we already did 0. 0 squared minus 1 is -1. And then I have 1 squared minus 1 is 1 minus 1, which is 0. And 2 squared minus 1 is 4 minus 1, which is 3. All right, so I've got 5 points here. This table of values corresponds to 5 coordinate points. -2, 3, -1, 0, 0, -1, 1, 0, and 2, 3. I want to make a note here that I've got some x and y intercepts here. So I made a point about if you have a point where the y value is 0, That's a special point on the x-axis. So let's point those out. -1, 0 and 1, 0 are lying, I'll just say are on the x-axis. They're on the x-axis. We call them, in the context of like a graph of an equation, we call them x-intercepts. Because that's where this graph is going to cut through the x-axis. Okay, and the point where x is 0, 0, -1 is on the y-axis. That's a y-intercept. We call it a y-intercept. A y-intercept. Okay. All right, so that was just like a little detour there. The point is we're trying to get enough points until we can become convinced about the shape of this y equals x squared minus 1 graph. So let's see if these are enough points. So I'm going to write down my points. My points are, the points that I have are -2, 3, -1, 0, 0, -1, 1, 0, and 2, 3. So I'm going to graph all 5 of these points and see if it gives me some kind of shape that I can then draw on my XY plane. Oh, I should put tick marks on my graph. All right. Okay, so the point -2, 3, that's at -2 for x and up at 3 for y, so that's roughly there. -1, 0, -1 for x, and that's on the x-axis. That's an x-intercept, -1, 0, right there on the x-axis. 0, -1, that's a y-intercept because the x is 0. That's a y-intercept. 0 for x, and down here at -1 for the y value. 1, 0 puts me there. 1, 0, that's the x-intercept there, the second x-intercept. So these are the two x-intercepts, and this one is the y-intercept. And then 2, 3 for that last point. Okay, so I am getting a shape out of this. And what I do is, earlier I said that y equals x squared minus 1 is when I graph it, is going to be infinitely many points that satisfy this. So like not only these 5 points and beyond, but all the points in between, all the little fractional points that we do not want to calculate, all the little decimal points in between, they also satisfy this equation. So what we do to draw a picture of what I just said, to get every single point in between and beyond, is we connect the dots and we put little arrows at the end, just like that. So that's how we connect these points. And show that the infinitely many points that satisfy this equation, And just for a vocabulary term, this shape, this sort of U shape, is called a parabola. This shape is called a parabola. Okay. Now, we will often fall back. Later, we're going to be talking about graphing functions, and the functions are going to get very complicated. And you can always fall back on graphing points this way. So that's why we're learning this. That's why I'm not just coming out and telling you what a parabola is and how it moves around and stuff. We're talking about how to graph points, and then from those finite set of points, get a picture out of it. Because that's a really good thing to fall back on if you ever don't know how to graph an equation. So let's try another example. I guess I haven't started the enumeration of the examples yet, so I'll call this example 1. Sketch a graph of y equals 2x plus 3 and state its x and y intercepts. Is y'all's Wi-Fi working now? Kimberly, is it working?
It is a little bit. It kind of goes in and out.
Okay, okay. Yep, that's JSU Wi-Fi. All right. Okay, now, if we want to sketch a graph of this and state its x and y intercepts, we have some work to do, but first I want to say, what do I want to say? Note that you may not need to make a table of values to graph this, because you may already remember how linear equations work, like this whole slope y-intercept thing. You may remember how to graph this without having to make a table. So I'm going to make a note of that. Note that you may have an idea about how to graph. Note that you may have an idea about how to graph y equals 2x plus 3 without a table of values. Without a table of values. But we will do a table, of values for practice. And I will connect it back. I will connect it back to the ideas that you may already have about this linear equation, about the slope and the y-intercept. Okay, let's make a table of values. Oops, I need my the brown marker. Okay, so I'm just gonna label it x and y this time. Instead of putting the 2x plus 3 there, I'll just put a y. I'll go ahead and find those same 5 x values. Are those always going to be the x values you want to use? Not necessarily. They're a good start, but sometimes if your graph is shifted around, you may want to change, and we'll get to some examples of that as well. All right. So the y values for these 5x values, -2, -1, 0, 1, and 2, start at the top at -2. -2 times 2 is -4 plus 3. -4 plus 3 is -1. Okay. Next x value is -1. -1 times 2 is -2 plus 3 is a +1. Now here comes the y-intercept. When x is 0, that's a y-intercept. When I plug in 0, 2 times 0 is 0 plus 3, just gives me 3. Okay, so that's lining up with what we recall from the linear function thing, where rules where this number, this constant, should be the y value of the y-intercept, and we're seeing that that holds true here. And when I plug in x equals 1, 2 times 1 is 2, plus 3 is 5, and then finally the x value of 2. 2 times 2 is 4 plus 3 is 7. All right, so we're getting those 5 coordinate points. We see that the y-intercept, how do you find the y-intercept? You set x equal to 0 and you solve. So we already found that. The y-intercept is going to be that 0, 3. So it's the coordinate point 0, 3. What about the x-intercept? We didn't get that here. So how to find x-intercept? Well, to find the y-intercept, you set x equal to 0 and you solve. So to find the x-intercept, set y equal to 0 and solve. set y equal to 0 in what? Well, in the equation. So y equals 2x plus 3, but if I'm setting y as 0, 0 is 2x plus 3. And now I need to solve for x. So I'll subtract 3. Subtracting 3 on both sides gives me a negative 3 on that left-hand side. So I've got 0 equals 2x plus 3, and I'm subtracting 3 from both sides. And then I'm going to divide both sides by 2 to get rid of that 2 on the attached to the x by multiplication. I'm going to divide by 2. Inverse operation of multiplication is division, right? So I'm going to divide by 2 on both sides, leaving me with a negative 3 over 2 is equal to x. So I get a fractional number. That's okay. So my x-intercept then, the x value is negative 3 over 2, and the y, what's the y value? Well, it's what I forced it to be, which is 0. So there's my x-intercept. Oh, I should label it x-intercept. There it is. X-intercept is the coordinate point negative 3 over 2, comma 0. Okay, and now we also need to sketch a graph of this equation, which, by the way, I don't have the equation on this page. It's y equals 2x plus 3. Okay, so I'm going to put some tick marks on my graph. 3, 4, 5. And my graph is not very perfectly symmetrical, but that's okay. All right, so I'm going to graph these points. Now, does anyone remember how many points you actually, like, what's the minimum number of points you need to graph a straight line? Does anyone remember? Just 2. How do you graph a straight line? Oh, is that what you were going to say, Makira?
Yeah.
I think you might be muted. That's okay. Anyways, whoa, hang on. My volume's going crazy. What is happening? Okay. All right. So I've lost my train of thought. We only need 2 points to graph a straight line. Now we have 5, right, from our table of values, so we have more than enough. But just recall that to graph a straight line, you only need 2 points. Now, how do I know this is a straight line? Well, because I remember the form of a straight line. What if you didn't? What if you didn't remember? Well, then you would just go ahead and graph all 5 of these points. Negative 2, negative 1 is going to be right here in the third quadrant. Negative 1, comma 1 is going to be right there. Negative 1 for x, positive 1 for y. 0, comma 3 is going to be up here. 0 for x. Now notice I didn't graph my x-intercept, but where would it be? Negative 3/2 is negative 1.5. So it would be right between negative 1 and negative 2 on the x-axis. I just didn't graph it because it's fractional. I don't want to graph fractions. All right, 1, comma 5. 1, comma 5 is my next point, and 2, comma 7 is my last point. All right, so clearly it's a straight line. Clearly it's a straight line. Okay. Clearly it's a straight line. Now, I said I was going to connect your knowledge of the y equals 2x plus 3 with the slope of 2 and y-intercept of 3 back to our table of values. Well, I already talked about the y-intercept, right? We see the 3 there being the y component of the y-intercept. What about the value 2, that slope of 2? So what about the slope of 2? What can I say in our table of values? What about, because you may recall the y equals mx plus b thing where that value, the number 2, is m, which is the slope. So what about the slope of 2? Where is it in our table of values? Well, consider that as looking at the table of values and moving down on the x side, as x increases by 1 in each step, negative 2 to negative 1, negative 1 to 0, 0 to 1, 1 to 2, it's increasing by 1 each time in each little step here. As x increases by 1, y increases by 2. Okay, yeah, right. -1 to 1 is a difference of 2. 1 to 3 is a difference of 2. 3 to 5 is a difference of 2. 5 to 7 is a difference of 2. So as x increases by 1, y increases by 2. So the points, when you graph a new point, you go over 1, up 2. Remember rise over run? So the run is 1 and the rise is 2. So between each point, we rise, so rise in quotes, like moving up 2, and we run, so moving left to right, in this case right, by 1. And slope is equal to rise over run, right? The difference in the y values over the difference in the x values, rise over run, which we're getting here as 2 over 1, which is equal to 2. So it's all connected. You can see it in the table of values if you really pull it apart, kind of like I did here. You can see the slope also in the equation of the line right there attached to the x. Okay. We're going to talk about lines in a little bit more detail in section, I believe it's, I forget what section, like 1.5 or something. And we'll talk more about the distinct slope formula and different forms of straight lines. How are we doing on time? Good. Okay. Let's do something that I often skip in my 112 classes, and it always comes back to bite me, so I'm going to not skip it this time, which is to sketch a graph of the absolute value not function, it's the absolute, sketch a graph of the absolute value equation y is equal to absolute value of x. I typically skip this one just because, I don't know, I just feel like it's a bit weird and don't really think it'll be that useful, but we've already talked about absolute values, right? With the certain times when you're reducing a square root, you have to throw absolute values around variables. And this could be a useful example later on. So let's go ahead and get it out of the way now. First of all, we need to recall what an absolute value does. Absolute value takes in a number and it spits out a positive version of it. So that means if I plug in absolute value of 3, then it just, if the input is positive, then the output just stays the same. The point is the output should always be positive. And if I give it a -3, it gives me a 3. Okay, so that's how absolute value works. It always spits out a positive. Now I can start slapping negative signs outside of the absolute value if I wanted to make this answer negative, but that's not what we're doing here. It's just a plain old absolute value. You give it stuff and it gives you positives, always. If you give it a positive, it just returns the same value. If you give it a negative, it returns the positive version of whatever you gave it. And by the way, 0, if you give it a 0, it just gives you a 0. Okay, so how do we sketch a graph of the absolute value function? Let's make a table of values. And let's do -2 for x values, -2, -1, 0, 1, and 2. Just like we did before. Okay, let's see. I'm gonna try and call on y'all. If your screen's frozen, then just I'll just ask someone else. I think Aviana, you haven't said anything about your Wi-Fi being messed up yet. So can you tell me what the output would be if I put in a -2 for x here? Aviana?
Wouldn't it just be 2?
Right. It would be 2. And similarly, the next one would be 1. The next one would be 0. And then absolute value of 1 is just going to give me 1 again. And then, so not a lot of complication, or not a lot of calculations rather, to figure this out. It's just you just basically copy the values over, but just take any negatives away. Good. All right. Now, if I'm going to sketch a graph, I need to draw a graph. And by the way, since I see that the y values are all positive, I don't really need a negative y-axis. I don't need the bottom part of my graph because it doesn't go into the negative y values. So I'm going to, since I only went out to 2, the highest value is 2 in any direction. I'll just kind of extend my graph a little bit there. That's fine. Okay. So at -2 for x, I'm at a +2 for y. At -1 for x, I'm at a +1 for y. At 0, so this graph goes through the origin at 0, 0. At an x value of 1, I'm at a y value of 1. And then at x value of 2, I'm at a y value of 2. Okay. And is this enough for us to see the shape of the graph? Yes, it's like a straight line going this way, and then it turns around and it's like a V shape. Straight line going that way. It's basically 2 straight lines just stuck together. It's like a straight line where the negative half has been flipped up to go to keep going positive. So it's like a V shape. Let's make a note about the x and y intercepts. Does it have any x and y intercepts? Yes. Note that this graph has an x-intercept. An x-intercept should be the point where the y value is 0, but that's this one. So it has an x-intercept and it's 0, 0. That's fine. And a y-intercept, but it's 0, 0, because a y-intercept should have an x value of 0. So the point is, when a graph goes through the origin, when it hits the origin like this, that 0, 0, the 0, 0 is an x-intercept and a y-intercept. Okay, so when a graph when it goes through that origin, then that point is considered as an x-intercept and a y-intercept. Okay. Example 3. Sketch a graph of y is equal to x minus 2 squared and find its intercepts. So x and y intercepts. I'm just saying intercepts here. So that means find all of them. So this is a case where we're going to want to, in our table of values, we're going to want to scoot our x values over because the x is being shifted by 2. Okay. Let me think for a moment. So when our graph is shifted, or rather when the x value has been shifted, this is a weird way of saying it. I'm being a little informal here, but that's okay. In other, like in this, when is the x value being shifted? When stuff is being added or subtracted directly from x. So the minus 2 is inside the parentheses with the x. It's not x squared minus 2, it's x minus 2 all squared. That minus 2 is directly subtracted from the x. So when the x value has been shifted like that, we need to adjust the table of values. I'll say TOV for table of values. Okay, now I know I'm almost out of time here, so I'm going to wrap it up now. So when the X value has been shifted, so how do you know when the X value has been shifted? You have to learn to recognize, oh, my voice. You have to learn to recognize it. You have to start recognizing when the X value has been shifted. And how do you recognize that? Well, when stuff is added or subtracted directly from the X. So if there's a square, it's like that -2 is stuffed inside with the X. And what do I mean by adjust the table of values? It means I don't want to pick the values from -2 to 2. I want to shift them over. So instead of going from, instead of -2, -1, 0, 1, and 2, I'm going to shift over to the right in order to make up for that -2. I'm going to use the coordinate or the X values 0, 1, 2, 3, and 4. I know I am running out of time. Let me just say, so instead of -2, -1, 0, 1, and 2, we use 0, 1, 2, 3, 4 to make up for, to balance out. So I'll say to make up for the two being subtracted from X. So it's like I'm adding 2 back to X. So make up for the 2 being subtracted from X in the equation. And next time, actually you could do this, you could do the little arithmetic and find the Y values on your own, but I'll pick up from here next time, find these Y values, and then we'll graph it. This idea about shifting it will make more sense once we have a picture and you'll see that the entire graph has actually been shifted. So I will make sure that to make more sense out of what I wrote down here next time. All right, you guys are good to go. Stick around if you have questions. I'm going to stop the recording now.